Everyone, and welcome back to my channel AM Economist. So, if you are following my Econometrics playlist, you will know that I have covered classical linear regression model extensively in my playlist. If you haven't watched that playlist, I would recommend you to do so. Now, today we will be starting off with something called the multiple linear regression model, which is just the extension of CLRM. It is also known as MLRM, right? So in CLRM, what we have said is that we have one dependent variable and one independent variable in the model. Now, if you extend that notion and if you add more than two independent variables, two or more than two independent variable or explanatory variable in your model, then you will land up to something called multiple linear regression model, right? As simple as that. Now, in today's video, we will be talking of about what the model looks like, what are the elements are there in the model, and also we will see how to estimate that model. And we will use our same old technique called the ordinary least square method of estimating the multiple linear regression model, and we will see what is the estimated value of the parameters, right? Slope parameter and the intercept parameter. So this is the agenda for today's video. And in CLRM, if you remember, we had two normal equations and two unknowns, and we have solved that out. And in this particular model, we'll also see that the normal equations will be there. They will be more in number, and the calculation will be a little more complex, right? So let us see how we can go about it. Let's start with the model. Suppose y equals to f of x2, x3 be the functional relation between y and x's, and we assume that f is linear, then our regression model will be so what will be the model? Let me write yi equals to beta 1 plus beta 2 x2i plus beta 3 x3i plus some error term ui for all I is from 1 to n, right? So this is what the model looks like. So see here you have one dependent variable yi. Suppose for example, you can consider suppose the dependent variable is salary, and it depends on two independent variables or two explanatory variables. So what explains salary? The first could be your level of education. Suppose x2i is the level of, I'm just giving you an example, right? yi is the salary. We are saying that salary depends on the level of education and the level of experience, suppose, right? So if you want to model this particular situation, then you have to take the help of the multiple linear regression model. So this is the classic multiple linear regression model, and you can basically extend this number of independent variables. Here for our simplicity, we have taken only two explanatory variables, but in general, you can extend this model to n explanatory variables according to your need, right? Now, what is this parameter? Here you have how many parameters are there? Here you have three parameters. Beta 1 is one parameter, beta 2 and beta 3, right? So these are the parameters in your model, and ui is normal, the error term, right? Stochastic error term. So beta 1, here this beta 1 is known as the overall effect. This is the overall effect, or also known as the general effect. It is known as the overall effect of the or the general effect on salary. So if you take, if you go by this example, this will be the overall effect or the general effect of salary if you go by this particular model. And now you have two other parameters, beta 2 and beta 3. They are known as the average effect. They are the average effect of education and experience on salary. So for example, if you go by this example, it will be beta 2 will represent the average effect of education on salary, and beta 3 will represent the average effect of experience on salary. And this is how you interpret the parameters of your particular model, right? So if this is the kind of model that we are talking about, what will be the estimated value of beta 1 cap, beta 2 cap, and beta 3 cap? That is what we always looking for. When we have introduced the two variable model, then also we had two parameters, beta 1 and beta 2, only two parameters were there. And the first step was to estimate those two parameters, and that is what we will do in this particular scenario as well. We will try to estimate in this video what will be beta 1 cap using OLS, beta 2 cap using OLS, and beta 3 cap using OLS. And that will give us the model estimation, right? So before going into that, in order to find out the estimated model, what we start with, we always start with the residual of the model. What will be the residual? The residual is given by ui cap, right? It is simply ui cap, which is yi minus yi cap for all I from 1 to n. So residual is basically the actual values of the dependent variable minus the estimated values of the estimated means the predicted values. This is the actual value and this is the predicted values. Actual values of xi and this is the predicted values of xi. So this difference will give you the residual of your model. Residual is the estimated error, right? Now we shall use by OLS. We minimize the error sum of square or the residual sum of square. Residual sum of square with respect to beta 1 cap, beta 2 cap, and beta 3 cap. And this will give us the normal equation. This will give us the normal equations. So let's see what will be the normal equation. Summation I from 1 to n ui cap square is simply summation I from 1 to n yi minus beta 1 cap minus beta 2 cap x2i minus beta 3 cap x3i and a whole square of that. This is the residual sum of square. So what will be the normal equations? The first normal equation will be del RSS del beta 1 cap equals to 0. This will be the first normal equation. The second normal equation will be this will equals to 0. And the third normal equation will be del RSS del beta 3 cap equals to 0. And this will be the third normal equation, right? I hope this much is clear. This is absolutely the same what we have done in classical linear regression model as well. Now, if you solve this first normal equation, what will you get? Start with the first equation. If you simplify, so basically we are partially differentiating this residual sum of square with respect to beta 1, right? If you are partially differentiating it with respect to beta 1, what will you get? You will get 2 summation I from 1 to m yi minus this portion is as it is minus beta 2 cap x2i minus beta 3 cap x3i, and then you will have a minus 1 because see here beta 1 cap, the coefficient is minus 1. So basically by the chain rule, this will be there. And now if you take this to the right hand side, you will get summation I from 1 to n yi will be equals to what? It will be simply n beta cap, beta 1 cap plus beta 2 cap, summation I from 1 to n x 2i plus beta 3 cap, summation I from 1 to n x 3i. Right, I hope you can see this thing. Let's call it equation number 4. Now from the second normal equation, in the second normal equation, I have to partially differentiate it with respect to beta 2 cap. Right? You have to differentiate this particular RSS with respect to beta 2 cap. If you do that, what will you get? 2 summation I from 1 to n yi minus beta 1 cap. So you can do it along with me manually so that the concept becomes clear. Beta 2 cap x2i minus beta 3 cap x3i, and then by chain rule you will have another term. See here, what is the coefficient of beta 2 cap is minus x2i, minus x2i, and this will be equals to 0. Again do the same thing. Here you will have summation I from 1 to n yi x2i. So you have to multiply this thing yi x2i and then put rest of the things on the right hand side. You will get beta 1 cap summation I from 1 to n x2i beta 2 cap. So here I don't have anything to explain. It's just calculation. You have to do it on your own in order to understand it completely, right? I'm not explaining anything. I'm just solving this equation. x2i, x3i, right? And this will be equation number 5. And then you have another thing, which is from the third normal equation. So here you have one normal equation extra because you have one independent variable or one parameter. The number of parameters you have, the equations, number of normal equations should be same, right? So here you have beta 1, beta 2, beta 3, 3 parameters. So you are having 3 normal equations. So we have seen what will be this thing, what will be this thing. And now let's see the third normal equation. So partially differentiate with respect to beta 3. So if you do that, what will you get? Summation yi x3i, and here you have beta 1 cap x3i plus beta 2 cap summation x2i x3i plus beta 3 cap summation I from 1 to n x3i square. And this will be equation number 6, right? Yes, we had 5 there. It will be equation number 6. Now what will you do? So you have equation 4, 5 and 6. Now the next step will be what? From equation number 4. So basically we are using equation number 4. In equation 4, if you divide both sides by n, right? This is the equation number 4, right? This is equation number 4. Divide both the sides, both the left hand side and the right hand side by n. And then see what will be the scenario. Divide both sides by n. If you do that, on the left hand side, you will have 1 yi and divided by n. And then on the right hand side, n beta 1 cap upon n beta 2 cap summation I from 1 to n x2i upon n, and then you have beta 3 cap summation I from 1 to n x3i upon n, right? This is what you will have. So what can you say about this particular term? What will be this term? This term is simply y bar. And here this n and n will cancel out. This is beta 1 cap plus beta 2 cap into what is this particular thing? This is x2 bar. And what is this particular thing? This is x3 bar, right? I hope you can see this thing. So what will be beta cap, beta 1 cap OLS? It will be simply y bar minus beta 2 cap x2 bar minus beta 3 cap x3 bar, right? So this is how you find out the estimate of the intercept coefficient. Beta 1 cap, if you go by the model, see, this was the model. So beta 1 cap was the intercept coefficient, what we call as the overall effect or the general effect. And this will be the estimated value, the OLS estimated value of this intercept parameter, beta 1 cap, where this beta 2 cap will be, we have to estimate this, we will come to that. This is beta 2 cap OLS and this beta 3 is beta 3 cap OLS, right? So if you have the value of y bar, x2 bar, x3 bar, and this OLS estimates of beta 2 cap and beta 3 cap, you can easily find out what will be the estimated value of beta 1 cap, right? So let me write, this is the estimated value of beta 1 cap using OLS, right? I hope this much is clear. Now, how to find out what is beta 2 cap OLS and beta 3 cap OLS? For that, you have to perform another exercise. Let me show you. Next step would be to put this beta 1 cap, so this particular estimated value of beta 1 cap, put this beta 1 cap into equation 5. Into equation 5. So let me show you what was equation 5. Equation 5 was this. Now, where is the beta 1 cap here? See, here you have the beta 1 cap. So instead of beta 1 cap, instead of this beta 1 cap, put this estimated value of beta 1 cap, what we found out in the earlier step. So if you do that, see, what will you get? Summation 1 to n. I know the calculation is, little lengthy, but if you know the process, you can easily do it. It's just calculation. So instead of beta 1, put y bar minus beta 2 cap x2 bar minus beta 3 cap x3 bar. And then you have summation I from 1 to n x2i. Then you have beta 2 cap summation I from 1 to n x2i square plus beta 3 cap summation I from 1 to n x2i x3i, right? So rest of the things are the same. So I have just, replaced this portion. Beta 1 cap is the intercept, this OLS estimate. Now, if you have this, you can do one thing. What you can do, write this thing as it is. And then from the right hand side, what will you do? You will minus y bar into this. So this term and multiplied by this term, right? So basically they are in the multiplication form. So multiply y bar and summation x I from 1 to n x2 and take it on the left hand side. So you will get y bar into summation I from 1 to n x2i, right? And I will reveal in a while why I have done this. And now on the right hand side, what you have to do, take beta 2 cap common. So here you have beta 2 cap, here you have beta 2 cap. So, and then you have a multiplication also here. So if you do that, take beta 2 cap common. So first term will be this particular term, summation I from 1 to n x2i square. And then minus what you have here. If you see this particular expression, this thing multiplied by this thing, these two things, you will have x2 bar and then summation I from 1 to n x2i. Right? I hope you got the process. And again, take beta 3 cap common from the rest of the terms. If you do that, you will have summation I from 1 to n x2i x3i. And then minus, here, see here you have 1 beta 3 cap term. So this will be x3 bar summation I from 1 to n x2y. Right? So this is the thing that you have to perform. So simply what I have done, let me explain it. So basically what I have done, here, see, here you have this expression in the multiplicative form. This expression is in the multiplicative form. So I'm multiplying this y bar by this thing and then taking it to the left hand side. So this is the LHS. This is the LHS that we are having. Now multiply this particular thing with this particular thing. Here you have beta 2 cap. Here also you have beta 2 cap. Take beta 2 cap common and you will get this first term in the RHS. And then take beta 3 cap common from this expression and from this expression. And you will get this third term, right? This second term, the right hand side. And let us call this term. What will be the equation number? I think it's equation 7. Right? Yes, we had equation 6, so it will be equation 7. Now do the same thing. See, we had another normal equation. This is the third normal equation that we had. Here also you have this beta 1 term, so do the same thing. Replace this by this estimated value. So it will be from equation 6. From equation 6, we will have summation I from 1 to n yi x I. Then substitute y bar beta 3 cap x2 bar, beta 3 cap x3 bar. Then write everything as it is, x3i, beta 2 cap summation I from 1 to n x2i x3i plus beta 3 cap summation I from 1 to n x3i and a whole square of that. Right? This is what you will have. Again, you have to do the same thing. Multiply this and take it to the left hand side. So the left hand side will be yi xci and then minus y bar into summation I from 1 to n x3. This will be the LHS. And in the RHS again, take beta 2 cap common. So you will be having summation I from 1 to n x2i x3i minus x2 bar summation I from 1 to n x3i, and then plus you will have beta 3 cap summation I from 1 to n x3i square x3 bar summation I from 1 to n x3i, right? And this we call as equation number 8. Now using this equation number 7, so here we had equation 7 and here we had equation 8. We have to reduce this thing. We have to convert this thing into deviation form. Now, please see this expression and please see this expression. So the two expressions that we had in the left hand side. So can you say anything about these two things? Can you find out a deviation form? Can you find out a deviation form of these two things? What will be the deviation form? It's very known to us. Can you identify that? You can pause the video. You can think for yourself. And you will be getting something like this. We know that summation I from 1 to n, what is xi minus x bar and yi minus y bar? What is this expression? If you simplify this expression, you will be getting this kind of a thing. Xi yi minus y bar into summation xi. Right? Can you do this thing? Can you prove this thing? And this can, again, if you write it in the deviation form, this will be simply small xi and small yi. As I have told you, small always represents the deviation form. Deviation from the arithmetic mean. Deviation means deviation from the arithmetic mean. So where small xi is this, small yi is this. So can you prove this kind of thing? Prove this thing. So basically you just have to expand this, nothing else. So summation I from 1 to n xi minus x bar. I am doing this particular thing, but the next thing I'll give you as homework, please do that. Xi yi, and then you will be having x bar into summation I from 1 to n yi, and then you will be having xi into yi, then you have minus x bar into yi, then you have y bar into summation xi, and then you will be having n x bar y bar, right? If you expand this, you will be getting this. Now, I from 1 to n xi yi, keep this thing as it is, summation I from 1 to n xi. And now x bar, instead of this yi, can you write something? What can you write instead of summation yi? It will be simply n y bar. And then you have again n y bar. So this n y bar will cancel out and be getting this particular expression. So this is how you derive this particular, right? And this is also in the deviation form, summation I from 1 to n xi y. Now, can you find out any similarity? Can you find out any similarity anywhere? From this expression, see, this is summation xi yi minus y bar into summation xi. And see this particular expression, summation yi xti minus y bar summation xti. So what can you say about this? What will be this in the deviation form? What will be this in the deviation form? Please pause the video and think. It will be summation xti into yi, right? Please compare this. This is summation xi yi, so it will be simply summation xti into yi. And similarly, for this particular expression, what will be this? This will be simply summation x2y into yi. I hope this is clear. This LHS is done in the deviation form. Now, for the RHS, you have to take a look at another particular observation. That will be summation I from 1 to n xi minus x bar whole square. What can you write about this in the deviation form? This is simply summation I from 1 to n small xi square, right? Now, if you break this thing, you will have summation I from 1 to n xi square minus x bar into summation xi. Can you prove this thing? I want you to prove this thing, right? If you know, just, apply the formula, or let me show you this thing. Let me show you this thing. I know it might be a little hard for some people, so let me do that. So expand this formula. This will be simply xi squared plus x bar squared minus 2x bar into xi, right? This is the whole square formula, a minus b whole square formula. Now apply the summation on each of this term. Plus this will be n x bar squared minus 2x bar into summation I from 1 to n xi, right? So keep this term as it is. Now plus nx bar squared, and now again instead of this x bar, write nx bar. So it will be I from 1 to n xi squared plus nx bar squared, and it will be minus 2 nx bar squared. So summation I from 1 to n, this is xi square minus n x bar square, right? This is the form that we got. Now see, here you want to reach this particular thing, so you have to manipulate this second term. So nx bar can be written as what? Nx bar square. So you have nx bar into x bar, right? So nx bar is simply summation I from 1 to n xi into x. I hope this much is absolutely clear. So this directly comes from the average formula, the mean formula, 1 by n summation xi. So n x bar will be summation I from 1 to n xi, and this x bar was still there. So that is how you derive this particular thing. I hope this is clear. Now, why did I say this thing? Again, you have to find out the similarity. Can you find similarity of this thing with anything in equation 7 or 8? See, can you find something? Take a look at this particular thing. And take a look at this particular thing. Can you say something? I hope you can. So what will be this particular term? If you compare it with something that we have derived, it will be, yes, it will be, this expression will be simply summation I from 1 to n small x to I square. I know it can be a little hard, but please pause the video and think, you will get this. And this will come out to be summation I from 1 to n x 3I square, right? This is what we have got here. Here we are taking into account only xi, but there the variable is x2 and x3, that will be reflected in this deviation form. So instead of xi, you will have x2i square and x3i square, right? Now comes the final step. Express equation 7 in terms of this deviation form. From 7, if you put all these deviation term, you will be having the final term will be this, equals to beta 2 cap summation I from 1 to n small x to I square plus beta 3 cap summation I from 1 to n x to I x to I. See, this will be the thing. Right? I hope this is clear. So this particular thing can also be said as summation x to I x to I, right? This will be simply summation I from 1 to n x to I x to I. Again, by the similar formula that we have derived here. This will be summation x to I x to I. And in equation 8, what will be equation 8? From equation 8, this will be simply summation I from 1 to n x3i yr, and here you have beta 2 cap summation I from 1 to n x2i x3i plus beta 3 cap summation I from 1 to n x3i square. So let's call this to be equation 9. And let's call this as equation number 10. Now, what can you say about these two equations? If you observe carefully, these are two equations and two unknowns. So beta 2 cap is one unknown here, beta 3 cap is one unknown here, and rest of the things are, in the deviation form, and they can be found out. Summation x2i yi, summation x3i yi, everything. They are the, in the functional form x2i x3i, right? So this, we can say the system is solvable since we have two equations and two unknowns. The system is solvable, right? How do you solve this equation? So suppose I call this term to be A, I call this term to be B, and this is term C. Suppose this is D, and this is again x2i xi is term C, and this is summation x3i term. So this is E. So this system of equation can be written in this particular format. So A will be equals to beta 2 cap or D beta 2 cap plus C, and then D will be C beta 2 cap. Sorry, here you will have a beta 3 cap also. And this will be E beta 3 cap. Right now it is reduced. Now you can simply solve this two system of equations. Right? If you solve this two system of equation and then get, write instead of A, write summation x to x, y. So basically you can simplify this by reducing this thing into this particular format, and then if you solve this system of equation, what will you get? You will get the OLS estimates of beta 2 cap and beta 3 cap. Since I have told you that here you have two equations 9 and 10 and two unknowns, only two equations and two unknowns, so the system is solvable if you solve this simultaneously. So from 9 and 10, what we will get? This is the main important thing. That is why we started off. So this will give you the estimate, the OLS estimate of beta 2 cap will come out to be this. Summation I from 1 to n x2i yi into summation I from 1 to n x3i square minus summation I from 1 to n x2i x3i into summation I from 1 to n x3i into yi upon whole divided by summation I from 1 to n x2i square summation I from 1 to n x3i square summation I from 1 to n x2i x3i and a whole square of that. So this will be the OLS estimation of the slope parameter beta, beta 2 basically, not beta 2 cap. This is the estimation. So beta 2 cap is the estimated value or the OLS estimated value of the slope parameter beta 2. Please, in order to solve questions, you have to remember this formula. So this formula is very important. This formula is very important. And now the final formula will be the formula for beta 3 cap. Again, if you solve those two system of equations, you will get this particular thing. It will be summation I from 1 to n x3i into yi summation I from 1 to n x2i square minus summation I from 1 to n x3i x2i summation I from 1 to n x2i into yi whole divided by summation I from 1 to n. So the denominator remains the same. Only in the numerator, the terms are different. In the denominator, you will see same terms are there. x2i, x3i whole square, right? And this will give you the OLS estimation of the slope parameter beta 3, right? And this will be all about the estimation of OLS in the multiple linear regression model. So see, please remember also this particular thing. So these two formulas are very important. Whenever the question comes and you have to manually estimate the MLRM model, you have to apply these two things. Convert everything into the deviation form and then just simply use this formula. I have, given you the derivation because I have seen many students who are struggling to find how to get this estimated form. So they just try to memorize everything. But now, if you have seen this video entirely, you will know how this formula is coming from, right? This was the main agenda. This was the main intention behind this video that I want to, clear everything out so that you don't have any doubt anywhere and you don't have to memorize anything. You have to just follow the process. Econometrics is all about following the process and structuring everything and go by logic, right? So we have step by step understood how to find out the estimated value of the slope parameter and the intercept parameter. So see, here you have first term is x2i yi and here the first term is x3i yi. So you can remember by this suffix also. For beta 2, the first thing is 2. And here for beta 3, the first term is x3. And now it will be the reverse. Here you have summation x2i square. Here you are talking about x3, but here you have summation x2i square. But here you have x3i square. So only the suffix 2 and 3 are getting interchanged, nothing else. Similarly, for these three things also, you can find out your way of remembering this thing. Here you have x3i 2i, here also you have x3i 2i. And here you have x3i and here you have x2i, right? So you have to find out your own way of remembering the numerator because in the denominator, you don't have to remember anything. They are the same. They are the same, right? So only the numerator part you have to remember. And now when you have this beta 2 cap OLS and beta 3 cap OLS, if you have this, you can go back to the intercept parameter. So let's go back to the intercept parameter here. See, in the beta 1 cap OLS, you have y bar minus beta 2 cap OLS. So this beta 2 cap OLS will be what we have derived, right? Beta 2 cap OLS is what we have derived. Then you have x2 bar minus beta 3 cap also what we have derived just now. and then you have XTY. And this is how you find out the intercept and the slope parameter of the, OLS, using the OLS method in the MLRM scenario. So what we have done today, we have learned about the model, what is the structure of the model, and then we have gone into the estimation process. This is the model. And for estimating the model, we have to minimize the residual sum of square, what we always do in case of ordinary least square method. So in residual, this is the residual we started off. And then we found out what will be the normal equations. These are the, since you have three parameters in your model, you have three normal equations. And these are the, simplified version of the normal equations. Once we have that, what we did was that in the first normal equation, if you divide both sides by n, you will get the intercept estimation. Now, in order to find out the slope estimation, what you have to do, you have to, reduce everything into the deviation form, right? You have to reduce everything in the deviation. So remember this thing, that in the intercept, when we found out the estimate of the intercept, this was in the original form and not in the deviation. So this x2 bar and x3 bar, they are the original mean of the x2i's and x3i's, right? They are not in the deviation form. Deviation comes when we are talking about the slope estimate, because they, help us to find out a, simplified version of the estimate. That is why we have followed these steps. We have found out how to convert everything in the deviation form. I've given you all the steps. You can do it for yourself. And the only homework that I'm giving is this. This is the homework. You have these two equations and these two unknowns. Please solve them and try to verify that yes, this will be the form that you will be landing up to, right? I hope this video was helpful to you. If it was helpful, then please give me a like and do subscribe to this channel A in Economics, so that I get motivation to make all these videos for you absolutely free of cost. All you have to do is to hit the subscribe button and help me grow my channel, right? Thank you so much for your time. And in the next video, I'll be continuing with this MLRM model. I'll be talking about the relationship between simple and multiple regression coefficients. What will be the interrelationship between them? We are also talking about the partial regression coefficients, right? So all these things will be covered. So thank you so much for your time and stay tuned for the next video.